Inside the box, you'll have your pouch, which is fine. You have your meter, pair of probes, just your standard jack. So a little bit about how to use it. You have a spin dial here, your display down here. So let's say you want to check voltage, you can turn on the light. If you want to select between AC and DC, you hit the select button and it'll select between the two. You can also do it like a hold. So if you see like a voltage or a reading you want to hold, you can hit hold. You have your various settings up here. Auto, then you'll go to diode, continuity, capacitance, and so you can just go select. When you go back to the first one, it's going to be your resistance readings. You have a hertz or frequency readings. You can also do percentage. That's not something I usually do, so I'm not going to discuss that. You have amperage, 40 amperes, 400 amperes, and then non-contact voltage. I'll show you those in a minute. You also, whenever you're in your amperage readings, you can zero it out. And I've found this one to be pretty good. I've done some testing, you'll see later in the video, where I actually find this unit to be pretty good, and it's a keeper. You can also change your current to AC or DC. I'm not going to check AC because I don't typically care about AC, and I don't really typically care too much about DC, but I do run into a few projects here and there where I want to know, and I want to know the amperage, and I'm running somewhere in the 20-25 amps range, and my Fluke only goes to 10, so I don't want to go too far. So in order to do like a reading, you would take and clamp this around one of the two leads. So if you have a DC circuit, you have two leads. You'll have a positive and a negative. If you plug it in one way or hook it around one way, you'll see a positive. If you hook it the other way, you'll see a negative. They have a little arrow here. It's hard to see because it's orange and an orange background, which they're trying to tell you which way the current flows. They have a negative and a positive. But ultimately, for me, I don't care about direction of current typically. So it's just something to know. Checking DC voltages on the MK06 versus my Fluke 177. And I have a digital power supply here that I'll just be cranking it up by 1 volt each time and see where we measure. I do have it in DC. I'll turn on the light here. It's easier to read. Can't see it, but there's a little DC voltage. Then obviously my Fluke here is on DC voltage. And as you can see here, my battery keeps popping up, which means I need to replace the 9 volt, which is fine. So this is voltage there. You can see the DC. So I have it on 1 volt, and the backlight is very, very short on the MK06, but it's not that bad. So we'll go up. Here's 2. As you see, it's reading identical to my Fluke. Here is 3. Still very close to the Fluke. 4. 5. 6, 7, 8, 9, 10, 11, 12, 13, still pretty good. 14, 15, 16, 17, 'As you see, it's pretty good. There's some small deviation there on DC, but overall it's pretty good. It does deviate a little bit from my Fluke. Here's 30, 31. Not bad overall. Some good things. The light, when you turn it on, doesn't change the reading. So we'll see. I'll check out some amperage readings, things like that, and see kind of where we are. But so far, it looks pretty good for DC voltage. Here is the Excel sheet that has the DC voltage. As you can see here, I went 131, and here are the readings versus the Fluke. As you can see, they're pretty close overall. The deviation is pretty small. Very satisfied overall with the reading, and as you can see here from the line, there isn't much where they deviate from what it should be for the DC voltage. 31 reads 31. Plugged into a house outlet, we're seeing 121.5 or so on AC voltage, which is pretty good because that's about what I normally have. I mean, fluctuates, AC voltage fluctuates, so 121 is about right in the groove for AC. You have to use the top here, and you have to select it up here. And as you see here, it lights up, just letting you know that it's there. Comparing some different circuit elements on the Mastfuyi MK06 versus my Fluke 177. The very first thing you want to do is verify you have no voltage. So we're going to verify here your little spin dial to voltage. We're in DC. I'll turn on the backlight here. Maybe it makes it a little easier to see. And as you can see here, I have no voltage, no voltage anywhere here, which is expected because I have nothing plugged into my breadboard. But on my breadboard here, we have some LEDs, we have some Zener diodes, or rectifier diodes, we have some capacitors, and we have a couple of resistant elements. These resistors are just a 1/4 watt. I like to double check the probes and just make sure that they're reading pretty close to less than 1 ohm. So about 0.5, which is really kind of expected there for that. So then we'll go ahead and we'll just double check. I'll turn on the backlight to make it a little easier to see, but we can double check this resistor, and it should pop up as 10.3, which is not too bad. Then the next one is 215.4, 1938 for the 2 kilo ohms, and approximately 1 mega ohm. So we'll just do it side by side with the Fluke. So again, this was 10.3, and then with the Fluke here, it's hard to see, but it's also showing 10.3. 10.3. This was 215. Now we're 215. We're at 199 or 1988 kilo ohm, and this last one's going to be approximately 1 mega ohm. As you see, the readings for ohms are pretty spot on between the two units. I'm going to test some other ones just offline and put that in a graph, but I fully expect this to be pretty close to each other. Next up, we're going to go ahead and check some of these diodes. So to do that, you'll select the diode, which is the little arrow with the line. And then what you have to do is you have to select the right one. I'll turn on the backlight here so you can see this is in ohms. You'll hit select one time. It'll pull up the diode setting. For the diodes, you have to make sure you have your probe the right way. So an example here is in this green one. It'll light up whenever we get it. And the forward voltage is about 2.3, which is pretty much in line with the green one. If you had the two reversed, it won't light up. And it'll just say overload. So pretty normal there. So let's go back to it. 2.308 versus the Fluke. So I have the Fluke here. Again, select the diode. You also have to hit the select button on the Fluke. So for the green one, we're about 2.2 versus 2.3, so it's a little different there. Now we'll move on to this top yellow one. We're showing 1.95. For the Fluke, we're showing 1858. We'll move on to this back green one. Excuse me, back red one. We're showing 1823 on the MK06 and about 175 on the Fluke. I also have these two here. These are bad diodes or bad LEDs that I have. So we can go ahead and check those as well, so you can just kind of see what that looks like when you have a bad one, because there are some different readings you can get. So it's showing a 0, which it should because I have them backwards. And then going forward here, it's showing, let's see if I can get it to read. Showing about 0.125. And what that means is that there is some voltage that gets through, but not enough to make it light up. And the same thing it's a much lower number on the Fluke at 0.07. And that is essentially because it's open. This one burned out. So it's kind of nice to know that you'll see that sometimes. You can also check resistance of these, which I'll go through in another step. So over here, you're looking at about 3 forward voltages for the voltage, 3 for the forward voltage, versus we get nothing over here. And I'm not sure why that is, but this one's also a bad LED. The two on the bottom here are bad LEDs. So I'm not quite sure why that does that, but it does. Now we'll just check a regular diode, a regular rectifying diode, and see what it looks like here. As you see, it's again backwards. And as you see, we can get a forward voltage of approximately 0.63, which is within the range of this particular one. And here it's 0.6, so there is some delta there. Not enough for me to say, hey, that's crazy, I wouldn't buy this one. So far, this has been a pretty good cheap unit. It's about $30. So next we'll move on to the next section, select button. So we'll compare the two of them together. So for this guy, and it takes a few seconds to charge it up, it's showing about 70 nanofarads. So 70 nanofarads. And this one's showing 80 nanofarads. So they're pretty close to each other. 70 versus 80. It's a little bit of a change, but not enough for me. This one showing about 10 microfarads. And about 10.7 microfarads. So again, pretty close there. This bigger one, we are looking at 104.7. And this one's 105. So, I mean, they're pretty close there overall. I do have a couple other ones I might check. But capacitance, pretty close, except when you get into the smaller ones. But probably still good enough. The next section is probably going to be some amperage, so we can see where we're at there. Now we're going to do some DC amperage readings. And I just have my power supply here, and I will change the amperage coming out. My leads will go to in series with my Fluke on these two. And I'll make sure I put this on amps. I'll put this on amps, and this one has to go through the clamp because it cannot read via the plugs. So we'll go ahead and set up our meters. Again, we're going to go to amps. We have to go to DC. Right now it's in AC. So DC amps, that's on the Fluke. And on the meter here, on the MK6. Now you have to zero this, which is one of the things I do like. As you see here, we're reading about a ½ amp negative. If you hit 0, it'll zero it out. So we're going to do some readings here. We're going to go up to 1. As you can see, the Fluke is reading 0.996 amps, and the MK06 is reading 0.96. So it's a little off, but pretty close. We'll go up to 2. So Fluke is 1994, and the MK06 is 190. On the meter we got 2, or on the power supply we have 2. Go to 3. I'm only going to go up to about 8 for safety reasons. So at 3 we have 2992 on the Fluke and 290 on the MK06. So 4 on the power supply, 3990 on the Fluke, 390 on the MK06. 5 on the power supply, 5 on the, 4.989 on the Fluke, and MK06 is 4.88. 6 on the power supply, 5.989 on DC amps on the Fluke, and 586 on the MK06. And 7 on the power supply, 7.01 on the Fluke, and 6.89 on MK06. Go up to 8. 8 on power supply, 8 on Fluke, and 7.88 on MK06. I guess we'll go up to 9. 9 on power supply, 9.01 on the Fluke, and 8.9 on the MK06. I am going to stop it there because the Fluke has a max of 10, whereas the MK06 in theory can go 40 or 400 if you put it there on the 400. However, I don't believe that to be something I'm going to test, at least not in this type of video. So overall, I would have to say the MK06 is pretty good, and it's going to be my new go-to for around the house. It is not as good as my, professional level Fluke, but it is pretty good, and it's going to stay part of my work box, my toolbox.